The BBC is here, and Ian Stewart, who's just making his way round to his seat now, is joining us. Ian is an honorary fellow and a member of our External Relations Committee. If you're not already watching his series on plants, do, because that is a wonderful introduction to a lot of the evidence from the rocks on which I'm going to base this talk. And I emphasize evidence from the rocks because you might be surprised that there was a convergence of views between the President of the Geological Society and the committee led by Colin Summerhays. Where are you, Colin? The specialist group that produced, thank you, the Geological Society policy statement on climate change in November 2010. Well, don't be surprised. All of us have been looking at the same evidence from the rocks. And what I'm planning to say this afternoon is pretty much what I'd say if I were invited to step down to Westminster or Whitehall and talk to the people there about how can we convince ourselves that we really do have a problem. The truth, as Al Gore famously said, is really inconvenient. I put it to you that the existing arguments of the climate scientists have failed to stop the increase in carbon emissions. That's not necessarily casting any aspersions on their scientific validity, but their political effectiveness is not at all obvious. I'm suggesting that it is time for a new independent line of argument to be put firmly into the public debate on this matter, and that is the evidence from the rocks. If I start behaving like John the Baptist, ring the bell out there and stop me. I hope to stick to the rocks. And what I'd really like to do now is get in a bus on this pleasant February afternoon and head north up the Great North Road and go into the fields of Hertfordshire and show you some 55-million-year-old rocks so that together we can explore some of the issues I'm going to be thinking about this afternoon. We can't do that, but we do have a movie.
Bryan Lovell. I'm Senior Research Fellow in Earth Sciences at the University of Cambridge, and I'm President of the Geological Society. And here I've got my favourite rock. It's very rare, very hard. It was formed 55 million years ago at the time of a significant natural warming event in Earth's history, and it gives us vital clues bearing on present-day concerns about climate change. 55 million years ago, this was a beach, Hertford by the sea. And if we look across that chalk valley to the north of us, at what passes for a hill in Hertfordshire, we can imagine what happened. My feet are on the chalk. The chalk contains angular flints. When the chalk was lifted up out of the Cretaceous ocean and exposed to weathering, the chalk was dissolved, leaving these flints. They became rounded on the seashore that ran through this area 55 million years ago. That beach was lifted up, formed land, and that land surface was subjected to a major warming event, the evidence for which is in the silica cement lay between the pebbles on this beach. Then, as we move towards the heart of this specimen, we can see the fine white sand cementing the flint pebbles, and then finally, when we get into here, this is cemented so much by silica, the rock is so hard that it actually splits right across the flint pebbles rather than round them. It's commonly said that we're carrying out an experiment with this planet and we don't know what happens when you dump billions of tons of carbon into the atmosphere rapidly. The consequences for the planet are survivable. For us, they might not be. If we continue to pull the carbon trigger, we risk a repeat of those dramatic events 55 million years ago.
Museum for permission to use that piece of film, which to the horror of my children is on a continuous loop. Their worst nightmare, Dad on a continuous loop. Now, let's just consider, I was talking there about our attitude towards this planet, what the planet can tell us, what messages we may draw from that, and how we might in turn behave towards the planet. So let's just go back and look at the real voice of historical truth, which for me is always a poet, and let's see what Milton thought about mountains. As if on earth winds underground or waters forcing way, sidelong had pushed a mountain from his seat, half sunk with all his pines. Here's one of my favourite field areas above the town of Canmore in the Canadian Rockies. There's Milton. And here's Milton again, this time on sea level. The ark no more floats, but seems on ground fast on the top of some high mountain fixed. And now the tops of hills as rocks appear, with clamour thence the rapid currents drive towards the retreating sea their furious tide. That is the Bridport sandstone looking west down the coast towards Lyme Regis, a coast now a World Heritage Site where many of us have studied rocks and the rise and fall of the sea level. But there is Milton, pretty firmly subscribing to the notion of Noah's Ark, which though the flood was in the contemporary view created through divine agency, nonetheless mankind was given the power to save all the other creatures. In contrast, we enter an age of observational science, one of the heroes of which is Lavoisier. And here he is, appropriately surrounded by flasks, indicating his deserved reputation as the father of modern chemistry. But before this chap was taken to the guillotine on some trumped-up tax charge, he had also made some extraordinarily powerful geological observations in the Paris Basin. And one of these, published in that amazing year of 1789, he describes and then tries to interpret, separating the two, as he should. He describes rocks which a series of alternating layers of rocks, some containing marine fossils and some containing non-marine fossils. And clearly, on the evidence of those rocks, it was impossible to conceive of the rocks on Earth as a whole as having been created in a single flood. The evidence, the observational science, indicated the contrary. There have been repeated rises and falls of the sea. And here, another piece of favourite scenery of mine. This is Jebel Hafit in Arabia. You see in the distance there the ancient oasis town of Al Ain, and here are some hills that look pretty substantial. But Tennyson, by the 19th century, had taken us into new territory when we look at features such as this. The hills are shadows and they flow from form to form, and nothing stands. They melt like mist, the solid lands, like clouds, they shape themselves and go. Now, this is mid-19th century. Evolution is, the notion of evolution is about to change forever the way we think about ourselves in relation to other forms of life, and change the way we think about ourselves in relation to this planet. This is an era when we are seen as almost wholly subordinate to nature. Our one redeeming grace is that we can begin to understand it. But we are now, and this is really quite recent stuff, and I think an appropriate topic for this series of lectures, which with characteristic corporate imagination Shell has agreed to sponsor. I echo Ted's compliments to Shell. Geology and Man, what a title for an oil company to sponsor. But this is a question for you. And it isn't very often that we're picked up in nature. Maybe we don't need to be with geoscientists that are already in-house. But following a conference that took place here last year, that quote appeared in the Leader. Used to dealing with heavy subjects. And my answer, not the answer given in that copy of Nature, is there. I think it's yes. If we keep on dumping carbon into the atmosphere, we will indeed create in the geological record evidence that would lead future generations of geologists to conclude that the boundary of a geological epoch has been created by our activities. Now this leads to a nice dilemma for Jan Zelašević, who is a leading proponent of the notion of the Anthropocene, and also happens to be one of the people who's going to be sitting in arbitration on this as part of various stratigraphical commissions. Now, there is a nice little bit of geological politics in this, because if using really strict criteria, we geologists decide that we haven't actually done enough, created enough change on the planet to recognise a new era, do the deniers then have a field day? Does Lord Lawson come down here and mock the geologists in Burlington House? Or is it possible to put the argument beyond reasonable doubt? Forgive this rehearsal, this short tutorial, but before we get stuck into some of the observational science, I think it might help us just to remind ourselves of some basic facts about the sun and the earth and heat. Coming up through each square metre of the floor of this lecture theatre is something like 1/10 of a watt of energy. 2,000 times, more than 2,000 times that amount of energy is coming in from the sun. But, and this is where the numbers in this whole business get quite intriguing, the heat coming from within the earth can build mountains and it can move continents. The heat within earth builds the mountains, you could say the heat from the sun destroys them. There are periodic tick-tock variations in heat from the sun, which we can use to create high-definition geological timescales, which are essential for us in trying to draw any conclusions from past episodes of climate change and bring those onto a human timescale. Until recently, we simply couldn't do that. Now we can. And then there are episodic, not tick-tock, variations in events, volcanic events, earthquakes, and these controlled by events in the mantle, and I'll refer a little bit more to that in a moment. So the climate is controlled both by this heat from the sun and from the earth. And even though our activities are again an order of magnitude less than the heat coming up through the floor of this lecture theatre, by releasing carbon dioxide, we can have quite an effect on this planet. Let me just stop for a minute. Am I the only person who's quite hot in here? Yeah. Shall we see if we can get some of the high-powered heating on? Can we have the AC on? Thanks. I saw a few of you fanning yourselves. I assumed it wasn't because you were getting overexcited. So let's get into this in a little bit more detail with that framework. The episodic, the periodic, the input from the sun, the astronomical timescale, the episodic events, controlled ultimately by loss of heat from deep within the Earth. And let's pick up this theme of carbon and what role carbon plays in all of this. Of course, there is a natural cycling of oil and gas. As an old oil and gas man, I would estimate that the half-life of a natural deposit of gas or oil is of the order of 50, 100 million years. And here, for example, is gas, natural gas escaping on the flanks of Kamaki Valley, north of Baku in Azerbaijan. And we can see this rate, we can calculate these rates of release of oil and gas. But of course, we have interfered with this natural cycle, and we have interfered with it in a quite spectacular fashion. If the normal expectation for a deposit of gas or oil is that it would remain there for 50, 100, 200 million, even longer, then we, Homo sapiens, have drastically changed that. This is 40's Alpha platform, and something like there were 4 billion barrels of oil in place originally at 40's oil field. Well over half of that has now been recovered. So through this platform alone, 500 million barrels of oil have passed in the last 30, 40 years. And we, all of us in this room, have been the beneficiaries of that, both directly in that it's helped us get around, and indirectly in that the wealth in the North Sea added at some estimates 5% to gross domestic product at peak production. But we thereby, in my case, unwittingly, until recently, dumped into the atmosphere a large volume of carbon, in far greater quantities and far more rapidly than would have been the case had the natural cycle operating at Baku or Pitch Lake in Trinidad, had that natural cycle been operating. So, beyond reasonable doubt, we've dumped since the Industrial Revolution by burning fossil fuels, coal, oil and gas, and in particular now by burning still an awful lot of coal to generate electricity around the world. We are dumping a lot of carbon. Now let's just consider what happens when carbon is dumped. And the geological record tells us something quite interesting. It says whatever the starting conditions, whatever the positions of the continents, whatever the temperature of the planet at the time, each time there's been a natural pulling of the carbon trigger in the last couple of 100 million years, it's been broadly the same result. And clearly the planet has coped very well with that result. It has changed the course of evolution from time to time, but it could be tricky for us. And here you'll see I'm restraining myself from the John the Baptist Act. That is a phrase, Colin, is that a fair reflection of the Geological Society view? I'm not speaking for the Geological Society, I'm speaking for Bryan Lovell, but it will be tricky. That's all we're saying. We're not going to tell you in detail what's going to happen, we just say it'll be tricky. Now, the best analogy is the 55 million year warming event, and the climate change statement that was released by an expert team brought together by my predecessor, President Lynn Fosdick, that reported to Council under my impartial chairmanship early in my presidency. That report tells you quite a lot about that warming event. And it was also the subject of a conference that we ran here jointly with the British Ecological Society, when scientists from all over the world looked in detail at how you know this carbon was dumped into the atmosphere in these past events, what the composition of that carbon was, how fast it went in, and what happened. And that first statement I've got there is an important one. It's a very remarkable thing because, for example, the 183 million year warming event and the 55 million year warming event, much the same outcome regardless of the starting conditions. So let's look at some of this evidence. Here is a core from beneath the deep sea floor in the western North Atlantic, Blake Nose. And this is the rock that was analysed in a famous paper in Nature in November 1999, which we can study on a human timescale. We can look at this with the astronomical timescale developed by the great late Sir Nick Shackleton and others. The banding in here can be interpreted, and we can divide these rocks up so we can see what happened on the order of 1,000-year intervals. And most recently, and this is important stuff published in Nature Geoscience within the last year, these are observations, and I keep using this word, observations of rocks in Spitsbergen, published by Kui and others in Nature Geoscience last summer, and you'll see there some of the geological detail. None of this airy nonsense about don't worry about the detail in this slide. Of course you worry about the detail in this slide. The detail is the essence of this thing. And you'll see a little bar there on the right-hand side, the red bar. That's the study area. Jane Francis of Leeds University, who was on the expedition, has very kindly sent me these photographs of the rocks they studied on Spitsbergen. And here's the field camp, which just makes my mouth water. Fancy sleeping in those tents and waking up and looking at those wonderful exposures of rock there. And here is the core. A core taken by a mining company, made available to this group. And on the strength of that, they made a really quite important observation that the input of carbon for the 55 million year warming event was about 10 times slower than the rate at which we're now dumping it into the atmosphere. So a year ago, I was talking on a similar theme in here, perhaps some of you were present at that talk, and I was saying we're a third of the way towards repeating the 55 million year warming event, and I couldn't separate the curves because I thought they were pretty comparable. Now I have to plot that image on a different scale because the input, our input compared with this rate of input, our input is going more or less straight up. We are just dumping comparable volumes very rapidly. And without grinding through too much consideration of equilibria, I think it's pretty obvious that if you test a system such as planet Earth by dumping a volume of material very rapidly, that is potentially trickier for us than dumping it more slowly. And here is an example of the kind of reconstruction which we will get eventually from the work of this Spitsbergen team. This is a picture shown with permission of Jane Francis. The artist is Nichols, and it shows not the 55 million year event, but it shows the Arctic about 100 million years ago in the autumn with a larch. Ian, what do you think about this one? Like it? Rather than Professor Stewart lurking in the bushes, you have an iguana one. Again, based on observational science, the footprints are there. So we will shortly, Jane and her artistic colleagues will be creating images of the 55 million year old landscape. Now, why is the old boy showing us, quoting all this poetry and showing us all these artistic impressions, you ask? I think you know why. I've said why in my abstract. We are not winning the argument by science alone. We need these images. We need Q, BBC, Guess, and Ian. We need to have these scientific facts explained in this creative fashion. Okay, back to the tougher science. What actually happened? At least 1,000 gigatons of carbon, 1,000 billion tons. So these are observations. This is stuff established beyond reasonable doubt. Global temperatures went up, and in the Arctic they went up out of proportion. So they went up globally by 5-6 degrees centigrade. In the Arctic they went up by 2-3 times that. The oceans became more acidic. We're confident that that happened, and I can happily describe to you how we know that. And there was extinction of life, particularly on the floors of the oceans, the floor of the deep ocean. And in a nice twist, early primates were encouraged by these dramatic environmental changes. Our ancestors appeared as a result of the 55 million year warming event, and the descendants of those early primates are now repeating that carbon dump. And my own attitude to this, which was sharpened by the arrival of grandchildren, was that unless you take a particularly lofty geological view of these things, you might want to think about whether you keep pulling that carbon trigger. Now here is an astonishing image that gives the lie to the hills of shadows, and they flow from form to form and nothing stands. Just occasionally, some hills do stand. This is not a landscape on the contemporary planet. This is the landscape you would see were you flying in from New York to Paleogene, Scotland, 55 million years ago, and as you looked out blearily from your overnight flight, as you came into the west coast of Scotland, here's what you would have seen. Now, that is not an artistic recreation. It's a mundanely produced, three-dimensional seismic artifact by my colleagues at the Buller Laboratories in Cambridge University. Hartley Roberts and Nicky White, the leader of our team, published this image, this astonishing image, within the last year, again in Nature Geoscience. And if you look at that landscape, the topography is of the order of the present-day Scottish Highlands or the Lake District, order of 1,000 meters total relief. You can see in that, as though it were the Thames Valley, river terraces. Indeed, my Cambridge colleagues have analysed these river systems as though they were present-day river systems, and have deduced from that the episodic uplift of this landscape. We can date it. We can date this extraordinarily preserved landscape as a result of the chance that beneath these rocks are marine sediments, above them are marine sediments, and thanks to the activities of the oil industry west of Shetland, we have not only the remote sensing from the 3D seismic, we have lots and lots of boreholes that have found lots and lots of lovely oil and gas. I don't give it up that easily. And we can date this surface at 55 million years. It went up and down nearly a kilometre, the order of a kilometre, within 1 million or 2 million years. And this wasn't a result of compression, it wasn't a result of faulting, it was a result of something passing below that first lifted it up and dropped it down again. If you haven't heard of this phenomenon before, I'm not surprised, nor have we. At first, we simply didn't believe the results. We couldn't conceive what it was that could lift something up this rapidly and this much and drop it down again without leaving a trace. Yo-yo tectonics. Well, we think we know the answer. We think it's a hot blob in the convection of the mantle far below early Scotland. And we think that is a prospective trigger for the 55 million year warming event. If you lift up an ocean floor, which may contain a lot of methane trapped as hydrates, and you lift it up this suddenly, that is a prospective trigger of the 55 million year event. Just before we leave that background and I get on to how we could tackle the problem, let me say that the fact that we are still wondering what triggered the 55 million year event does not take away from any message you may choose to draw from it. It happened. And we know the rate at which it happened and we know the volumes. That is beyond reasonable doubt. What we're working on is what the trigger might be. And my guess at the moment is that when we have looked at these various warming events in the geological past, we will find that the triggers are an intriguing combination of the periodic variations in input from the sun and episodic events resulting from loss of heat from within the Earth. And the hot blobs I just referred to would be an example of the second episodic event. Now, let me move on now to whether we can solve this problem, which I state there in the first comment. And in the second comment, as Ted indicated in his introduction, I'm laying it on my old buddies in the oil industry and saying, if we actually wanted to do this, we could put it back again. And we had something of a historic conference here with the American Association of Petroleum Geologists and the Geological Society of London on the storage of carbon dioxide. After a decade or more of pretty acrimonious discussion winging its way between one B. Lovell resident in the UK and the officers of the American Association of Petroleum Geologists, of which I'm a member, I finally thought that it was time we did something about this and made some common ground. And this very good conference we had here recently is a result of that. And I think we're having another conference in January. There's another conference here in January 2013. The oil industry is beginning to think hard about this, largely because by pumping carbon dioxide into the ground you can get out residual oil, which otherwise would remain there, but also because there are some people, including Shell, who, as you'll see, who thinks that this is something that should be done. So let me just go into my habitual boast about just how smart we oil folk can be. Here we are drilling on 40's platform, 40's Delta this is, we flew over 40's Alpha in the photograph I showed you earlier. Here are these muddy characters working at the behest of the chief sedimentologist, taking muddy oily core out, and here is the chief, clean as a whistle, smug, grinning away. Forget bonuses, this is the life. And here is a pore space in 40's formation. I've chosen some old photographs here. I'm going back to pictures that we took some 30, 40 years ago to make the point that the expertise in the oil industry about fluids and rocks and the fine details of rocks, that's a 4-micron scale bar there, we really know what we're doing when it comes to pumping fluids in and out of spaces in rocks. Here's an even higher magnification thing. This was a book of kaolinite grown between some quartz grains. This is all 40's formation. Is the oil industry going to help us? Well, I think that's a wonderful statement by Shell. That isn't the date it went up on their website, just happened to be the date of my birthday last year. And it's clearly it's not over. I've just indicated some aspects of the debate are going on now. Trigger for these past events. There's lots of research being done. But for business reasons, Shell's just said, forget it. We are now acting on the basis that anthropogenic climate change is a reality. And the second statement, James Smith is now retired, but before he retired he made the most powerful, accurate statement. doesn't let many people off the hook. Coal-fired power we know about. Those who think that the switch to gas will solve the problem, no, says Smith, and I agree with him. Still a fossil fuel. Run a lot of gas, you still have a problem with the carbon dump. And if we don't get carbon capture and storage proven and deployed over the next 10 years, then we will not fix climate change. I agree. Besides going back and worrying about hot blobs when I stepped down from being president of the Geological Society this year, I'm also throwing my lot in with some of the people formerly in the oil industry who are working on this problem of capturing and storing carbon dioxide. Now, you're going to get not only a little bit more poetry, you're also going to get an ominous ballad now, which I think is a first for this lecture theatre. Sorry, I'm not going to sing it. I've got somebody on tape who apologises he can't be here. He's going to sing it for you. The long street, to be prosaic about it, is the good old A10. And here's the map of it siding through Hertfordshire. And you'll see in this sketch the Paleogene rocks these outliers of Paleogene are grey coloured, and you'll see a few spots there where you find Hertfordshire pudding stone, the rock I was proudly displaying in the endless loop of film I showed you earlier. And to just introduce this topic,
toxic brew. The climate turns quite nasty when there's too much CO2. And yet we're cooking up the planet, though we won't stand the heat. And the proof is in the pudding stone, right beneath our feet. It took 300 million years to lay down all that oil and coal. We burned it like there's no tomorrow, with no thought for those who follow. If we don't get carbon neutral, put back what we take out, when those rising seas immerse us, our great grandkids will curse us. All the polar caps are melting, all the bears are on the run. Bencio could well become an island in the sun. But don't get too excited at this hedonistic whim. We'll have sabotaged the Gulf Stream, so the sea's too cold to swim. We're really cocking up this planet, though we won't stand the heat. And the proof is in the pudding stone, right beneath our feet. So take a walk up Ermine Street, where Romans used to tread, and farmers' ploughs have shattered on that rocky pebble bed. These are signs of seismic changes, echoes from the planet's past. The earth in time repairs itself. Mankind, we might not last. If we keep cooking up the planet, then we won't stand the heat. And the proof is in the pudding stone, right beneath our feet. Oh yes, we're cooking up this planet, though we won't stand the heat. And the proof is in the pudding stone, right beneath our feet.
there. And yes, that really is the lower library of the Geological Society of London. And those raucous people singing, some of them, I regret to say, possibly even the worse for wear, were fellows of the Geological Society, friends of the Geological Society on the evening of our inaugural Poetry Day. I risked deportation from the United States of America in the 1960s when I was, as Ted reminded me, a student at Harvard University, by founding with a wonderful lawyer called Bart Deems the Harvard branch of the Students for the Democratic Society. And forget that Berkeley's claims that they were the first to oppose the Vietnam War. They weren't. Bart was the first, and I joined in. And we earnestly, then I was then still, as I am now, quite an earnest fellow when it came to information. And I go to the library and get Le Monde and The Guardian and cut out what we thought was the truth about the war in Asia, and produced laboriously these sheets, reproduced these sheets for the old hand-turning process, and distribute them on campus, and I don't think they made any difference at all. But by God, when John Barnes took an interest in the war and started singing ballads, that was the change. So thank you, Mike Exel, Hertfordshire folk singer. The Bengio who he refers to is the posh bit of Hertford where he and I both live. Now here's Tennyson's Long Street, Ermine Street, and you're standing in the ditch. This is not a field trip for you. Your feet are on chalk. I hope you can see that. There's a bit of sand there just below the grass, and then beyond the fence you can see a purplish tinge in that ploughed field. Right. And now we've climbed up to the other side of the fence, and we're looking up across the field to what passes for a hill in Hertfordshire, and you'll see the purple bed there, the rocky pebble bed in Mike's song, and above that a brown look to the plough, and then the trees at the top. And the British Geological Survey have kindly put a borehole down through this hill, and the upper part is London clay, complete with shark's teeth, nicely dated at 54 million years, and down below in the ditch is the chalk, which we can say is about 85 million years old. So the stratigraphical precision here leaves quite a bit to be desired. This is a far call from that deep sea core I showed you, or the rocks in Spitsbergen. We are hanging a 55 million year age for the pudding stone below the London clay in this setting. And here is a lump of the pudding stone on Bessie Parkin's farm. Bessie billeted on her farm in the Hertfordshire countryside the people who were building the new A10 bypass that you will go on when you're next going to Stansted Airport from East London. And Bessie, who had been fascinated by Hertfordshire pudding stones since she was a girl living on the farm, insisted that as part of their responsibilities on the farm, the people building the road bring all the pudding stone they found when they were cutting through that hill to Bessie, as a result of which she now has the best ever collection of this rare rock. And you're looking at a lump of it there. Zooming in, there's the white sand you saw in the film. And this rock, this silica cemented rock that is characteristic, the formation of which is strongly favoured by high temperatures, is not found just in Hertfordshire at this stratigraphical level. It's also found in the Hampshire Basin, and in the village of Portisham, the most spectacular piece was used by John Galpin, who was the vicar of the parish for many, many years, and the inscription here suggests clearly that he was departing this life for a better, so certainly John Galpin reckoned he was on a fairly good wicket anyway, but just in case that didn't work out, he took the precaution of tucking his mortal remains beneath the toughest rock on the planet. In this case, the Hampshire pudding stone, uglier than the Hertfordshire pudding stone, but the same age and the same toughness. And we also have some recent work to report that will be reported at a meeting to be held here within the next 12 months, a joint meeting with archaeologists. We have findings of pudding stone from northern France, from the Paris Basin, from Lavoisier's field areas that contains fossils. So we're working on the pudding stone and its formation. But I mentioned the archaeologist, and I'm going to end with some artifacts, some rocks being used. And here is the upper surface of a fist-sized lump of pudding stone that was used on the evidence of this lower surface, either as a hammer or for grinding corn. I prefer to think of it as being used for grinding corn because that was essential to the existence of the Stone Age man or woman who owned this precious piece of rare rock and used it to prepare their food. And in by the same road that Mike refers to in his song, you can find other Stone Age implements made from the flint, which is far more common. And when you sit by that road, you sit in the copse where we made these wonderful archaeological and geological objects, and you look at the traffic pouring up the A10 going to and from Stansted Airport. You wonder how we are going to make the transition from the life we lead now. And I wonder who it was, what qualities it was in the society, the Stone Age society, that enabled that society to move from this culture to the very different culture depending on metal. It was certainly technical skills, there's no doubt about that, and the technical skills I feel confident we have. I refer to the ability of the oil industry to take carbon out of the ground. We can put it back again. We can do that, and we can do it with confidence. We can even satisfy the lawyers that we can do that safely. What is lacking is the leadership, the inspiration that this is something we should do. We have used dutifully our scientific prose, carefully edited, sometimes given freer form by my favourite editor, but generally circumscribed by our rules, quite properly so, because we speak and we write as scientists. We need help, and we need help from the poets, which I think may be forthcoming from the Society's own poet, Michael McKim. We need help from the musicians, from Mike Exel and many more like him. And we need help from those who guide a wider public through intelligent, imaginative and responsible use of television. BBC, are you listening? I mean, Ian, it is a treat to have you here. Thank you for what you are doing for us as a community. I think the time has now come to do what geologists have done over the years, which is two difficult things at the same time. One is to do our research and maintain absolute integrity in that research according to all the rules we lay down for the fellowship of this society. So if we don't know what we're talking about in our research, we shut up and we find out. But what we do has huge implications for society at large. And you gather that I, for one, am not minded to sit on my hands when confronted with that knowledge. I think we need to do everything we can to ourselves, spread this message from the past warming events, and we need to make new allies to do that. Thank you.
Well, thank you very much, Brian. We have about 10 minutes for questions, and in order that I don't naturally sort of tend to go over this one, I'm going to start tonight by asking people from this group. I normally start over there, you see. If you have any questions, the floor is yours. And by the way, if I do pick you, could you wait for the microphone to arrive? It's not so that people can hear you in here, but it's so that you can be heard all over the world via our website. So, any questions from this group? Okay, passing right along. Now for the central group. Yes, there's a gentleman there.
I'd actually like to understand more clearly what the evidence on the pudding stone is. I'm not a geologist. I understand there's some element of maybe some sort of cement being formed from a heating event, but I don't fully understand what that evidence is in the pudding stone. Sorry.
There is inevitably some discussion amongst the geologists about how you get this silica cement. But what we do know about its formation is that it is favoured by warm, wet conditions. And as always in geology, we go and look at the present-day planet and we find places where silica cemented rocks are common, and a very good spot for that is Australia. So we study the conditions there. We find forming in the soil horizons a lot of silica cement, and we conclude that this silica cement in the pudding stone is formed in a warming event. But you will recognize what I'm doing here. I'm using the proof in the pudding stone as a metaphor. If I need to carry scientific conviction, I would refer to the deep sea core and the Spitsbergen data. But the temptation for me to ascribe a 55 million year date to the pudding stone in the London Basin, the Hampshire Basin, and in northern France is very great, because all over the world, in the Bighorn Basin, for example, in North America, we find evidence that at 55 million years, we find the evidence of alteration of rocks at the surface of the planet associated with a combination of, in some cases, very greatly increased precipitation, and in all cases greatly increased temperature, surface temperature. So it's an aspect of that. But what we need to do, you and I, is go out to Bessie Parkin's farm with some of the people who are currently working on exactly the problem you've identified. Jenny Huggett of Petroclase is working on that problem and she'll be reporting back to this meeting here.
We have a question just here. What was the source of the 55 trillion tons of carbon that appeared in the ancient past?
The quantity, the best guess from Jerry Dickens about the volume is at least 2,000 billion tons, and you can get that you can get it in principle by destabilizing the methane hydrate that is currently trapping carbon on the floors of the ocean. So we have a present-day model for this, and if you were to increase the ocean temperature, or indeed to lift up the floor of the ocean in the fashion we know happened in the North Atlantic, the way I described, you would take that frozen carbon out of its field of stability and it will be released to the atmosphere. So the original suggestion from Jerry Dickens and others was that the main source of the carbon that gave rise to the 55 million year warming event was release of methane hydrates, rapid release of methane hydrates from the floor of the world's oceans. And there was then some discussion, saying, it was pretty hot before the warming event even took place. Would you still get methane hydrates forming in those conditions? And that's been answered recently, and it appears, yes, you could. There would be enough volume to do it. And the composition of the carbon that we see that was released is highly compatible with it being methane hydrate.
And is the rock
that was found in Hertfordshire, does that date from that particular time? Would that have been formed by compression and perhaps blast furnace type heat?
Our best, we know from mapping in the whole area of northwest Europe that there was an emergence of the chalk. The chalk sea disappeared. There was an uplift, the chalk sea disappeared, and those flints were formed. So the timing of the formation of the pebbles themselves, we're fairly confident, is 55 million years. The actual date, we're just hanging off the 54 million years of those rocks up the top of that hill there. We know it lies below there, and we know it's a continuous sequence. And so we're saying, and it's the wrong kind of geological argument, I may say, that we're working from that upper date and hanging this date. We have at the moment no way of ascribing a firm 55 million year date to those rocks, but we have got these fossil-bearing pudding stones in the Paris Basin, which we're working on.
Thank you.
Thank you.
Thank you. I'm going to move over now onto the third block because we're moving up to 4 o'clock. There are two people vying for attention at the back there. Thank you.
Isn't the bottom line of part of the problem, the vast and increasing human population? I know this is a political issue, but is there any way that this can be tackled?
Well, clearly on one line of argument the answer is yes, but I think the proper answer for me to give here is to say that whatever other problems the size of the world's population might be creating for us, we do already have the technology, and we certainly have, we could certainly create the financial structure whereby we could cope with the transition to a low carbon economy, continue to burn coal to make electricity in huge volumes in India and China and the USA in particular. We could bury that carbon and manage the transition, and we can do that regardless of the size of the world's population.
Thank you.
We've got time for one more question from this central block.
Excuse me. If the conditions 55 million years ago gave rise to primates and our descendants, wouldn't the layperson believe that that should therefore be, the warming effect should be good for us now? And why is it not good for us now? How's people like Ian Stewart going to make the lay people out there realise that it's not good for us now?
I think we should let Ian answer that for himself, but Ted's going to gong us out in a minute, but I'm going to suggest, if I may, Ted, in a moment, that we can extend the discussion and include those who still want to ask questions, giving people time to go out. You'd have to be quite optimistic to think that we could go through anything like a repetition of the 55 million year warming event without being put under quite a lot of pressure as a species. The point I'm making is that there was quite a change, there was quite a lot of extinction, nothing like the 65 million year extinction, but there were some pretty big changes, certainly in the ocean. The benthic foraminifera, the creatures that live right at the bottom of the ocean, were more or less wiped out. So there were very big effects on the ocean. The acidification changed a lot of the life forms in the ocean. So if I be quite specific, since we rely to a great extent on a lot of food coming from the ocean, we'd be in trouble there for a start. I think that it's in lofty moods, pre-grandchildren, I used to think, oh well, if we do heat up the planet, we do cook up the planet, in Mike Exell's words, so what? We will become extinct, we're going to become extinct anyway. Some other creature will come along and look back with morbid fascination, 55 million years' time. Goodness me, these people created a warming event, but wipe them out. I don't know whether it would wipe us out. That comes into the realm of prediction, which we geologists are not terribly keen on. All we say is that heating up the planet very rapidly, acidifying the oceans, starving the oceans of oxygen, which are things we are confident will happen unless we stop dumping carbon. We're just saying that may be a bit tricky for us to handle. How was that for not being John the Baptist?
Okay, since we've got a little extension, there are quite a few people in this block who wanted to ask a few questions, so if you'd like to raise your hands again.
And
then there's a gentleman here at the front.
So let me just say that if people have to go to catch the train, whatever, please go.
Don't hold back.
Don't hold back, just, no.
In trying to convince the decision takers to do something about this issue, you need to overcome inertia and the feeling that it's someone else's problem, and that thirdly, developing technology will partly solve the problem, as perhaps it will. A sentiment expressed at the City University lecture last week on energy demand and how we will meet it. What are your clear prescriptions for addressing this issue that, dare we say, a somewhat lay and simplistic set of government ministers might be induced to pick up?
What we have to do is so difficult for us to cope with. It's going to require such a change in attitude that we're going to need a huge depth of conviction. And you need the kind of conviction that makes a whole, I mean, I quoted the example of the United States in the Vietnam War. And eventually a whole nation switched from taking very emphatically one view to taking a contrary view. Now we're talking about a global change in attitude on an issue that's ostensibly far less immediate. It's tricky. I think that geologically it helps to say it's not hopeless. We need to hold the ring through to the middle of the century. I mean, elsewhere in other times in this room I've talked about the Princeton targets and the targets set there to just simply hold things as they are through to mid-century, by which time we may assume we will have the technology we need, in particular to harness the energy from the sun. What I can offer on behalf of the geological community and from the expertise of the oil industry, whether that's deployed within the existing corporate structures or outside it, is a way of continuing to burn fossil fuels, capture the carbon and bury it while we make our way towards the low carbon economy we have to have. And insofar as people in the oil industry are taking the discovery of shale gas as an excuse to postpone action, bluntly, they are wrong. The shale gas, were it to be extracted properly with minimum leakage, in order not to create the sort of problems we're suggesting will be created by the carbon dump, if that carbon is going to be burnt by us, like any other carbon we're producing from fossil fuels, it needs to be captured and stored. And the scale of this is stupendous. We need to create an industry on the scale of the present day oil industry devoted to pumping carbon underground to cope with this transition. Does that help?
Yes, it does, but may I, as someone both with a geological background and a general interest in this topic, suggest that the Geological Society and other professional bodies should be clear in their prescriptions rather than straying into bemoaning the scientific evidence. Politicians, sadly, need clear instructions, forcefully presented, and that scientists aren't always good at giving.
Thank you. I'll tell a brief comment. I mean, this is an exceedingly significant point. The limits of our abilities as an organisation are defined, I think, by our geological knowledge. Others can take that knowledge and use it perhaps in the more forceful fashion you suggest, or individual fellows may wish to do so. But as an organisation, we have to stick and say we know what we're talking to what we know we're talking about.
Okay, I'm trying to sort of do people in order. Let's look here. Let's next, there we go. And then let's look at the back.
Thank you. Touching on that geological knowledge, the 1 kilometre rise that you mentioned, and with some surprise I detected due to the hot blob in the moving in the mantle. Presumably that was an extreme event which caused the 55 million years ago event itself. But what observational science have we got to support that that's happening on a lesser scale, and has it happened in, have we detected that phenomenon elsewhere, and what's the current research on that?
The editor of the Journal of the Geological Society is yet to let my research colleague Stephen Jones of Birmingham University and me know whether a paper we've written on that very topic is acceptable. But I mean, broadly speaking, the answer is that this phenomenon is something that people such as Dan Mackenzie would predict. You might find these in the evidence of this activity in the geological record, but you're right, we were surprised and delighted to be able to find that kind of evidence in the geological record. It is a consequence of convection in Earth's mantle at a certain Rayleigh number. I mean, I can take you through all the science you like for a cup of tea in a minute, but we would predict this effect at the surface. The difficulty was we couldn't see how you could get the happy geological circumstance where you would actually get something like that recorded in the geological record, and the even happier circumstance that you'd have this intense remote sensing and drilling that enabled you to see what it was. Now we're getting our eye in. If the leader of our team, Nicky White, were here, he'd perhaps give me permission to show you some of the other images which we're getting from younger rocks, which show that this was a phenomenon that was repeated in the North Atlantic and episodically. So it's pretty real, and it's far too early to say with conviction that it was the trigger for 55, let alone million-year warming event, let alone other events. But it's a good candidate. We're quite confident of the age. It happened at the same time. There's no way the North Atlantic would have remained undisturbed at that time.
Question at the back.
Has the state of knowledge moved on? I'm pretty sure that the IPCC, in its fourth assessment, dismissed methane hydrates as being irrelevant. I think there were only 2 paragraphs on the subject.
Yes, the IPCC report is largely untouched by any of the topics I've been discussing here this afternoon. On the train on the way in, I was reading a review by Jerry Dickens, to whom I referred earlier, and Jerry says, and I'm quoting from his paper, I think 4 pages out of the 1,100 that are made up of the 2007 report, including the data at the back, 4 pages refer to past climates beyond the ice ages. So I think you ask, has it moved on? Yeah, it's certainly moved on. The methane hydrates remain, as they were from the beginning, a very strong candidate to be involved either in priming the gun, and the trigger was then pulled by a periodic event, a Shackleton event, or being the trigger itself.
Yes, and you mentioned ocean hydrates as opposed to permafrost and Arctic conditions, which seem to be far more vulnerable to climate change.
They would, we believe, not have been significant at 55 million years because the climate was already very warm. We believe there was no polar ice or permafrost at that time. I think Mike Laws, as a pudding stone aficionado, should...
Yes, you mentioned the episodic nature of these changes. Is there any evidence for carbon release being associated with the climatic changes much more recently and perhaps a lower scale from the Chromarian tropical conditions through the Anglian glaciation to the Hoxne?
I'm going to defer to Colin Summerhays on that one. Okay. So, Mike, you can pick on the vice president in the law library. I never heard him be so reticent.
I think for the sake of those who are too nervous to get up on their own and leave,
not an expert.
I'd like to say thank you to Bryan for exploring this aspect of what is undoubtedly a defining issue of our age. And as that last questioner indicated, it's not just about climatology. And there is something profound here that geology has to say, and it needs to be heard. So I'd like you to join me in thanking Bryan for today's lecture, and if you have any more questions, I'm sure I'd be happy to deal with them